Today we are going to describe how to remove moisture from the air, how you calculate the fresh feed, recycle streams, and product stream, how you will apply the concept of splitter and separator. So let's start. Have an example from air which is wet air, which containing moisture. We will remove these moistures, and by number of recycle streams, we may increase the quality of the reactants and as well as products. So let's start from the recycle process. Uh, In this recycle process, there is a concept of splitter point. When you have any splitter in your recycle streams, when in your reactive system, then the composition after this splitter and at the both points, here our one feed stream is coming to the splitter, which is splitting into two streams with the same composition. The composition exiting at the product stream and at the recycle stream will be the same. So this is our any reactive system reactor. The fresh feed is coming into the reactor and recycle stream is combining with the fresh feed. This is a mixing point and we get a mixed feed. It is also called combined feed or reactor feed. It is going to the reactor and where reaction takes place, and after reaction we separate out our desired product. But with when we apply the splitter, the composition of the both exit stream will be the same. But in this case below, we are the fresh feed is coming and the second stream is combining with the fresh feed and it join to the mixed feed and it becomes combined feed. And after that there is some separator. It is not a splitter, so the composition after this separator will not be the same. The composition here and composition in the second stream will be the different, because in case of splitter it split the same stream into two different streams but with the same composition. But any separator which have the same, which is separating the one input stream into two output stream with different composition. So recycling is usually done when a component in a unit stream is not completely processed. In other words, when you have one reactant which is not going to be converted 100% converted, so if you are limited reactant or any other excess reactant, when your reaction is not going to completion, then your unconverted reactant will go into the product and you will recycle that reactant so that the uh, further conversion must take place in the reactor system. So this is a bypass stream. Bypass stream is one stream which is in which our fresh stream skips our the process unit and combine with the exit stream. So the here we also apply here these. This is our splitter point. So the composition at the exit of this point, splitter is splitting one stream into two output stream with the same composition. So the composition here is same and also the composition here is also the same. So let's start our today's session. Uh, your fresh feed containing 4 mole percent water vapors. Fresh feed is to be cooled and dehumidified to a water content of 1.75% mole percent water. So we have applied the fresh water is fresh air stream which is containing water, which is wet stream which has moisture in it. It is going to do dehumidifier which remove the moisture from the air. So the moisture content in the air will becomes one from decrease from 4% to 1.74%, 1.34% moisture will be removed. So in the fresh feed, one component is air is water and other component is air. So when the composition of water is 4%, the composition dry air is 96%. Similarly, after the dehumidifier, the composition of water is 1.7%, the composition of dry air will be 97 point. You have to subtract 1.7 from the 100. Of steam of fresh air is combined with the recycled stream of previously dehumidified air and passed through the cooler. So this stream is we're combining the fresh feed with the recycled stream, and combined stream will go to the cooler. The blended stream entering the unit contains 2 mole percent water. So here the moisture already increased because we are combining the water with the air. In the air conditioner, some of the water in the feed stream is condensed and removed as liquid. So a fraction of dehumidified air leaving the cooler is recycled and remainder is delivered to our room. So the air which was in wet phase, which contains the moisture, it is dehumidified and it is now utilized in the room as a cooling purpose, as a drying purpose. So take a basis of 100 moles dehumidified air delivered to a room as basis of calculation. Calculate fresh feed. We are not we have no information about fresh feed. We have no information about moles of water condensed. We have no information about moles of dehumidified and recycled air. So let's start from diagram. So this is as you know, the in the question you have given the water content, that is 4%. So other thing will be your dry air. Dry air will be 1 minus 0.04. It will be 0.96 mole percent, and this is going to uh, your reactor, your dehumidifier. This dehumidifier, the recycled steam from this dehumidifier is combined with the fresh feed, and it becomes the combined feed or mixed feed. It contains the water as the moisture content from uh, has been reduced, water content has been reduced, and the moisture are gone into the air. So here the moisture are 0.023 mole percent of water, but the dry air is 0.97 mole. So this is going to dehumidify the this dehumidifier has decreased the moisture from the air, dry air. As you know, the moles of dry air are increasing, the moles of water are decreasing moisture. So here we have taken the basis of, this is a splitter. When we apply the splitter, it splits one input stream into two output stream with the same composition. You know that here the composition of water is 0.017 mole, and the composition of dry air is also 0.983. And after the in this exit stream, the recycle stream, and 5 moles, it also contains the same composition as the product stream. So now we start from degree of freedom analysis. Uh, First, we apply the overall degree of freedom analysis. In overall degree of freedom analysis, we have only two unknowns. One is N1 and second is N3. When you draw a boundary line across this air conditioner, you there is only two output stream. One is N1 output stream and second is N3 output stream. Both are unknown, and the third one is N2 stream. N2 stream is here. So you have two unknowns, and you may apply the two balances equations, one water balance and second dry air balance. So number of unknowns minus your degree of freedom is the number of unknown variables. When you separate number of unknown variables from the independent equations, then you get the degree of freedom analysis. So here two unknowns are, and two balances can be applied to two. When you subtract 2 from 2, it becomes 0. So 0 degree of freedom, it is specified system. So it is specified system. Similarly, we may apply the degree of freedom and mixing point. There are also two variables. One is N2 and second is N5, and there are two balances. One is dry air balance, and second one is water balance. So degree of freedom here is also 0. There, and after that mixing point, there is a cooler, which is cooling the air. Here are also two variables. One is N2 and second one is N4, and you may apply two balances. One is dry air balance and second one is water balance. So degree of freedom here also will be 0. So splitting point, there are two variables N4 and 5, and you may apply only one balance. Then degree of freedom is 1. So there is no need to use this calculation in the solution. So when we apply overall dry air balance, because dry air is also in fresh feed and dry is also going into the product, you know that there is 96% moles of dry air in the fresh feed, and 98 mole percent in the product stream after the splitter. So we have taken the basis of 100 moles of the product stream. So you may easily calculate the number of moles of dry air in the fresh feed, that is N1. Now, when you apply overall mole balance, N1 is equal to N3 plus 100, because 100 are exit product stream moles and N3 are exit dehumidifier section. So N1 is unknown, and 100 is also a figures. You may determine the N3 moles. N3 moles are 2.4 mole water content. And third one is your the number of fresh mixed feed. So when you apply imbalance and mixing point, N1 and N5 moles are streams are combining, and they're making N2 moles. You may easily put the values and calculate the recycled mole. Thank you. If you have any question, you may ask in the comments.